Hello everyone, I'm Frank, and welcome to Frank Puzzles, and this is today's challenging level puzzle, and it's called Vacancy Chain by Michael Lefkowitz. And here are the rules. Normal Sudoku rules apply, which means place the digits 1 through 9 once each in every row, column, and box. Each hermit crab has grown too big for its shell, and must leave it behind and move into a vacant shell with a larger digit, possibly one vacated by another crab. Crabs' paths move orthogonally, and orthogonally means that they share an edge. So these two cells are orthogonally adjacent. These two cells are not. They are diagonally adjacent. So the crabs cannot move diagonally. They have to move orthogonally. So it's in this direction, or this direction. Crab paths move orthogonally, can't enter the same cell more than once, and can't cross piles of rocks, which are here. Here. Can't enter the same cell more than once. So obviously it can't go here, then back into it. Adjacent digits on a path differ by at least 5. It doesn't say anything about crossing paths, though. That's interesting. Adjacent digits on a path. So this is the German whisper rule. So each hermit crab has to leave its shell. So it has to leave its shell and go to another one. Interesting. That means out of these, 7 of them, how many are there? There's 1, 2, 3, 4, 5, 6, 7. So one of them gets to go to the new shell, and all the other 6 have to go to the other shells, which is why they don't say anything about paths not crossing, because you have to essentially go into one of these so one of these shells must be vacant, and then this shell must be must have a crab go into it, right? And they have to leave, so therefore they have to form a vacant cell. So you always have to go to a larger number. The crabs have to go to a larger number. And along the path, it's always a German whisper rule. So basically, along the path, so say it was this one that went here, right? So say this was the path. Along this German whisper rule, it would have to be, if this was a 3, this would have to be an 8 or a 9 to maintain have a difference of at least 5 for adjacent digits. Interesting. And paths cannot cross across rocks. So paths cannot go something like this, right? It could go around, but that's it. And you can't enter the same cell more than once. Okay. And those are all the rules. If you'd like to play along, there's going to be a link in the description. I'm going to pause this for a small bathroom break first, though. Let me pause. And I'm back. And as I said before, there's going to be a link in the description. So if you want to play along, you could click on that link. And now I'm going to get started. Let's go. Okay. So each crab must leave its shell for another shell. Because of that, that means the shells have to be connected except for one. So then it has to form essentially some sort of like contiguous um, German whisper line from cell to cell, right? And it's all orthogonal. So this one cannot go here. It can only go here or go here, or it could go around here somewhere, but that's unlikely. Um. Hmm. This has to be a highest number, right? If it's not the highest number, okay, what happens if this is not the highest number? There's obviously one crab that goes there, right? Because each one has to go to a higher number. One of them has to be the lowest number, obviously. You can't have two lowest numbers. Because if you have two lowest numbers, where does the low number go to, right? So therefore, yeah, you have to have only one low number because it has to. Um, if there were not, say there were two low numbers somewhere here. If there were two low numbers, one of them would be left out, right? One could not go to its own, and it could not go to the other one. Everything else would be higher, so they couldn't go to those two, and therefore you wouldn't have enough shells for each crab to get to, right? So one of them has to be low, and then the low number has to be one of these unoccupied ones. Therefore, this has to be the highest one, right? If this is not the highest one, say this was the lower than the highest one, the highest one, crap, where does that go to? It can't go anywhere, right? So this has to be the highest one. Therefore, the highest one goes to here. The next highest one also has to go to the second highest one, right? So okay, there's an ordering of this, right? Each of these crabs have to go to a higher digit. The problem is there's only one extra shell. So therefore there can only be one extra one that you can go to, which has to be the highest of the remaining ones, right? So the highest of the remaining ones has to go here. Because otherwise, where else can it go? It can't go anywhere else, right? And you can't have two highest ones also, because you can't have two that are the same number, essentially. Because you only have one extra shell to go to. Since you have only one extra shell, that means the highest number has to be able to go to there. If there's two highest ones, that never works, because then they both can't go to the shell, because they would both be occupied. They would both occupy it, which is not allowed. Therefore, you always go from the highest one. The highest one in the occupied cells has to go to. God, don't know where my mouse was. Anyways, sorry about that. The highest one has to essentially go to. The highest of the occupied ones has to go to this empty shell, because it can't go to any of the other occupied shells. So, and it can't go back to its own, so it has to go to this empty shell. The second highest has to go to the highest shell, because it can't go to the empty shell anymore, and then the second highest doesn't have any other cell to go to, so it has to go to the next highest. So it always consecutive with each other, right? So you have the highest number in the occupied cells has to go to the second highest, or that has to go to the empty cell. The second highest has to go to the previously highest. The third highest has to go to the second highest, etc., etc., all the way down. So the thing is, we know that these numbers cannot have to be 1, 2, 3, 4, 6, 7, 8, 9. Because you can never have 5 on a German whisper line. So for that, so we have 1, 2, 3, 4, 5, 6, 7 occupied cells. What does that tell us? The unoccupied cell has to be a 9. Because we have 1, 2, 3, 4, 6, 7, and 8. That's 7 cells, and therefore the ninth one has to be there. And now, in addition, because of the way it works, since it's only orthogonal movement, you have a checkerboard pattern where you can have the highs and the other set has to be lows, right? Because you have to go low, high. So on a German whisper line, you can only alternate between going from the set 1 through 4, then the set 6 through 9, then back to the set 1 through 4. Because the difference between 1 through 4 to the next number has to have a difference of at least 5, which is 6 through 9. And the difference from 6 through 9 has to have a difference of at least 5 from that digit, which would be 1 through 4. So it always alternates. So you know for specific ones what the cells can be. So this can be high, this can be low, this can be high, this can be low. These can be high, these can be low, which actually tells us quite a bit of information then. So these are low, these are high, these are low. These are high, and these are low. And this is high. Right? Because we know everything has to be connected. So it has to have a connection somewhere with another shell. So you're always going to be connected to back to this 9, right? The 9 has to go down to an 8 somewhere. The 8 has to go down to a 7, which connects with a 6, which connects with a 4, which connects with a 3, which connects with a 2, which connects with a 1. So you're always going to be alternating over and over again until you basically have the correct ones. So because of that, we know then these have to be the blue cells. And we don't know all the blue cells. So we can remove all the coloring except for the shells. And then the red ones have to be here. So these have to be the highs. So except for these 3, we can delete these for now. Therefore, these are the lows, and these have to be the highs. So this is 1 through 4. This has to be 6, 7, or 8, 6, 7, or 8, 6, 7, or 8. So there has to be a connection between these 3 cells with two of them with each other, and then the 9 has to be connected to one of these 3 cells. Okay. Let's see. The 9. Where can the 9 be? Because remember, so the paths can cross. So that doesn't actually, there's nothing that blocks that, right? But the paths cannot enter the same cell more than once. So this is 9. It has to have one of the 8s go to it. Which is the question, though. One of them has to be 6, which means the 1 has to be right next to it. Yeah, in a sense, this is one large line, one large German whisper line, essentially. But it can cross itself as long as in the one where it's going through, it doesn't. Like, if this was 6 and 7, it doesn't go through it twice, right? Um, hmm. This is high again. So this is high. Could be any from 1 through 4. Um, we have 6, 7, and 8. The 4 connects with the 6, which is interesting. The 3 connects with the 4, and the 2 connects with the 1. So this cannot be, well, it could be 4, 9. But if that's the case, okay, so if this is the 4, it has to go out this way, right? Somehow. So can this be, if this is 4, this would have to be the 9 then. This would be low. This would be medium or high. This would be low. So we'd have a low, a low. So this would be all the lows. So it's possible. Hmm, 4, 9, 1, 2, 3, 1, 2, 3. Either this would be 3 or this would be 3, obviously. One, two, three, 7 or 8. 1, 2, 3. 7, 8, or 9. Hmm. So that could be possible. Hmm. 6 would most likely be here. So say this was 4, this was not 4, that's 6. One of these would be 1. It would be 7 and 8 then. 2 or 3. Hmm. Doable. Mm. I'm wondering also if it says it means can't enter the same cell more than once. That means crab pass can't, as a whole, can't enter the same cell more than once. Right? Because, hmm. Yeah, I think we have to maintain the assumption that they could enter the path right now. Maybe if we get too stuck on things, we would have to revisit that. Well, heck, I'm right now running into problems trying to just understand how this would work as uh interesting. So if this was 4, this would only enter in and exit out this way, right? So this would have to be 9 and it would have to enter in and exit out that way. I'm thinking that it can't be that can't enter the same cell more than once. It says crab paths can't enter the same cell more than once. So yeah, you're always going from a smaller to a larger one. It's never entering there, right? If you think about it. So that means, yeah, you can't have the same crab path enter in this way, right? So yeah, it says, since it says crab paths can't enter the same cell more than once. That means you can only enter the cell once for any crab path. It's not basically all crab paths can enter in it, and that makes a lot more sense in the sense of limiting the scope, right? Because if this could enter in this way, and another crab path could enter in that way, then there's so many possibilities. I don't think it's even solvable. So it has to be that you can only enter, and the way that's worded is says crab paths can't enter the same cell more than once. So therefore, it has to be all the crab paths cannot enter the same cell more than once. So that makes a lot more sense, which means this can't be 4. Because if this was 4, this would have to be not one of these two, both of these two would have to be 9, which is not allowed because this is 9. Same here. If this is 4, I guess this could be 9, and that can't be 9. So the 9 would have to be here, and then here, but that's not allowed. So this can't be 4 either. Then this can't be 4 because it would have to be surrounded by a 9 and a 9, which is not allowed. So this can't be 4. Therefore, this has to be the 4, which means it goes 9 and 9 or 9 and 9. We're not sure which. Because it must be surrounded by one unique digit. So it could be 9 and 9. It could be 9 and 9. It could be 9 and 9. It cannot be 9 and 9 here. Okay, so obviously this can't be 9. So this can't be 9. So one of these two is 9, and therefore this is always 9. So this is always 9 here. One of these two is 9. We're not sure which. So either this is 9 or this is 9. We're not sure which. This could be 4, 3, 2, 1. That's possible. So 4, 3. Can this ever be 3? If this is 4, it would connect to 3 here. Connect to 2. I don't think that works. Yeah, that doesn't work. So this can never be 3. Can this ever be 1? 4 to 3. I guess it could go around here this way. No, because then it would block off this, right? It would block this one from connecting to any of these 3. Well, I guess it can. If this is 1, that means this would have to connect this way somehow. To maybe this would be 3. This would be 4. No, it's not possible. Right? You have to, if this is 1, it would have to go all the way around here. And like, say we try to cut here. Then it blocks off this from this 9 connecting. So this can't be 1 either. This has to be 2. Which means it connects to both this one and this one. So we have 1 and 3. Could be 1, 2, 3, 4, something like that. Or 1, 2, 3, 4. Um, if it goes here, it cannot go here. So if it goes connect to here, this one's blocked from this one. These two. So that's not possible. So this can't be 6. What about if it goes here? If it goes here, the problem is, yeah, it still blocks then. I mean, I guess it could go something around, maybe? Say it went around. It could go around, then it could go back here. So say it went here. So say it went this way, right? It could go something like this. Could go something like that, then that, right? Yeah, so that's possible. So it could connect to here. It just cannot connect to here, right? If it connects here, I don't even know. I don't think there's a way. You connect here, but the problem is then this one be blocked from the rest, so that doesn't work. But it could connect around something like this. This is possible, so it could go this way. Or it doesn't even have to go that way, right? It could go around here to 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 here, right? So that's possible. Unlikely, but it's possible. So this one is ruled out though. These two have to connect. Yeah, this has to connect this way, right? These both have to be on the line because there's no other way to go for here. Oh, speaking of which, this has to connect both this way. Interesting. So either this is, yeah, because there's only two connections there possible here. This has to be 7 or 8, which means this cannot connect to this one. So this one has to go this way then. Does it? Yeah, to connect to the 2. Where else is the 2 gonna go? It can't go all the way around here and then because that would block everything else. So this has to connect this way. So this has to go here then here. Which means this exits here. I mean, it still could go all the way around, right? Oh, wait, hold up. We don't know if there's a 1 or 3. We don't know about that. So that one's not allowed. This one is still correct. So this has to be 1, 2, or 3. Because this is not the endpoint. This could actually be the endpoint, right? So this could be 1. If this is 1, 2, 3, that's 4. That's possible. Mm. Hmm. So we know specifically something's entering, something's exiting, but we don't know which direction's entering. We don't know which one's exiting. This must enter this way. We don't know which way it enters the other way, though. Hmm. If this is 3, it has to enter in and exit out these two ways, though. So therefore, it would be this way. This would have to be 8. It would be connected to the 2 then. It has to, well, we don't even know. Can it ever go that way? I don't think so. It could go this way. That's possible. Maybe. This would be 1 and 2. This would have to be 7. This would be 9. So say it tried going this way. This would have to be 7. This would be 1 and 2. This would be 1 and 2. This would have to be 9. This would be high. This would have to be low. So this would be 3 because it has to be next. So this would be 8. But that wouldn't work because there's no 9 here. So it cannot go this way if that's the case. So it would have to essentially go back to the 4, right? Which is possible, actually. That worked. 1, 2, 1, 2, 7. Well, okay, couldn't go there. Oh, that doesn't work. Okay, we've shown that doesn't work. This would have to be 9. But the problem is it can't go... We tried going down. That didn't work. And we try... If we go that way, this would have to be 9. And that doesn't work. So this cannot be 3, which means this is 1, and this is 3. So the 2 enters in one of these two. I guess the 3 could go here, too. The 1... Can it even go that way? So say it tried to go out this way. Well, I mean, I guess it could go something like this, or something like this. So say it went out something weird like this, right? This would be 6, 7, or 8. This could not be 2, so this would have to be 3. So this would be 3, this would be 8. This would be 9. This could be 2. Then it could be 7 or 8. This could be 1, 2, or 3. Um, so what happens if it goes this way? It would have to go here. So then this would be 2 and 3. So this would be 2. This would be 3. This cannot be 9. So this would be 8, which would force this to be 9. This cannot be 4. This would have to be 1. This could be 7 or 8. Either one works. So say it went here. This would have to be 7. Oh, it can't. Okay, so It would have to go like some weird way here, right? So I guess it could go something like this. I don't even know. So this would maybe it doesn't have to go that way. It could go this way. That could be 7 too. And then you could go here, which would be 2. Then you would have to go around. So this would have to go something like that, then that, right? This is seems like it's pretty difficult to go that way. Yeah, this would have to essentially go all the way around here. Or come, that doesn't work. Yeah, it cannot go around, so it can't go here. It would block this because the 4 has to connect with the 6 somehow, and the problem is that it would have to, yeah. So it cannot go this way, obviously, because it can't go 9. Can't go to the 4. So it, yeah. We tried going around all the way, but the problem is that it separates these two from each other and separates that from this one. So this one would be separated out. Even if you went around all the way around here to here to here, that just seems. And then yeah, actually no, it can't be because if it goes here, it blocks the 3 from the 4. So that's not possible. Yeah, so it does have to connect this way, but we don't know where it enters in. So it has to go here, which means this is 7 or 8. This could connect here, then here, then here, then here. That's fine. Can it ever go here? I don't think so, right? If it does do that, yeah, it blocks the 6, 7, 8 from the 9 unless it goes specifically all the way around here. But then, yeah, that would block. Yeah, that would block the 7, 6, 7, 8 from connecting to each other. So it cannot go this way. It has to go this way. So then this is a 9. Okay, so this can't be red. Oops, can't be red. This is a 9. This can't be 9 then. Wait, that doesn't work because we have a 3. It does have to go around then. Or no, it has to connect from this way. This can't be a 9 though because the 3 has to be next to an 8 and a 9. So therefore this is the 9 and it has to be, so this has to go out this way then. So the 4 has to go out this way. This is the arriving 3. So either way, the 9 has to be one of these two. This could be 8. If we tried going around here, then this blocks the 9. So this cannot go all the way around here. So this has to continue out this way. So it has to extend here, and then has to extend here, which means it must go here. So this one has to go this way, which means this is 2 or 3. This cannot be 6. This is 7 or 8. This is 1, 2, or 3. So we have a 7, 8, 7, 8 pair here, which means the rest of this cannot be 7 or 8. So this is 1, 2, 3, 4, 5, or 6. This is 1, 2, 3, 4, 5, 6. This obviously can't be 2. This can't be 3. Um, It could form some weird pattern here. It doesn't have to, but right. So this one specifically is not necessarily required. It could form some weird pattern here. It could form some weird pattern here. Um, it could go here, 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 here. So then this would be 8 and 9. So this would be 9. This would be 8. This would have to be 1. This could be 7 or 6, which would be next to 1, which is possible. I mean, technically, it could do something like this. Unlikely, though. Hmm. So we know 9 has to be one of these two. We also know 8 has to be one of these 3. Which doesn't tell us very much. Um. Hmm. Mm-hmm. 7, 8. 1, 2, 3. Mm. Can this ever be 6? If this is 6, neither of these can be 1. So 1 would have to be both here and here. So this can never be 6. So this is a 7 or 8, which forces this to be the 6. So this 4 has to connect with the 6 somehow. Um, hmm. Right, because if this was 6, this neither of these could be 1. So it has to connect to two different unique values, of which is 1, which doesn't work. So this is 7 or 8 too. So this has to be 2, 3, 5, 6. These are 2, 3, 5, and these are 6 possible. Interesting. Um, so this must go somewhere through here. It This would be low, high, low. Okay, so this wait, this can't work because this would be 1 next to 1 and 1. So this doesn't work. Hold up. Okay, we have a problem here then. Yeah, this can't be 6 because it would be next to 2 1s. So this can't be 6 either. This has to be a 6. Which means my previous something about this was incorrect. But yeah, this can't be 6 because this would have to be next to a 1 and a 1. Same problem here. This could be next to a 1 and a 1, which means this has to be the 6. Which means 1 has to be one of these two, which means this cannot be 1. So 1 is one of these two. So this has to be 6 then. And one of these is 1, and one of these is 1. So therefore, this is one of these is 1. One of these is 1. These are both blue, because it has to enter in. 1, 2, 3. 1, 2, or 3. This must connect. Ooh, this is rough. Which means this has to have an exit in entrance on both those. So this is 7 or 8. And this is 7, 8, or 9. In which, or the assumption that I made previously, which is crab paths cannot enter the same cell more than once, only applies for one path, each individual path. But that doesn't seem to make any sense because then that would make things so broad that I don't think it's solvable even. So one of these is 1. So say this was 2. We had 2. This would have to be 1. This would be 3. How does this connect here? 4 obviously connects with 6. But the problem is, how does... Yeah, it would block off 6 from the rest of 7 and 8. Right? Because any which way you do that, the 7 or 8 would have to go, essentially, would be blocked off. So that's not allowed. So therefore, this has to be 3, which means this is next to 8 and 9. So this is 8, this is 9. So this cannot be the 9, which means this has to be 9. So it has to exit out this way. This, either way, this has to exit out this way. So therefore, this is high, and this has to, actually, it has to be low. So this is low, and this has to be high, and this has to be low. Actually, it doesn't have, what am I talking about? It doesn't have to exit that way, it can go here. But the problem is this can't be 9, so therefore it does have to exit out this way. Okay, so therefore I was right. There, it has to exit out this way, it has to go this way, and has to go here. So it must exit out this way. This can't be 3. Um, so I guess it could go something like that, except it can't. This has to be 7 or 8. So the rest of them cannot be, it has to be 1 through 6. This has to be 1 or 2. This could be 1, 2, 3. Cannot be 4 because it has to be next to a 7 or 8. Hmm. So say this can't be connected this way. So this has to connect this way specifically. So this has to connect this way, which means this is the 2. So this is 2, this is 1. And it has to connect to the 3. So it has to immediately connect there. This obviously has to connect this way. So it could go here. That would be 1, in which case that's 2, in which case that could be 1. So one of these two is 7. So the 7 has to be one of these two. And this could be 1 or this could be 2. Hmm. So either this is 7 or 8, or this is 7 or 8. It has to connect through here somehow, right? So we have 1 of 7 or 8 is here. This can't be 6, obviously. This can be 1, 2, 3, 4, 5. This can't be 3 or 4, obviously. So 7 has to be one of these 3. Could be 1, 2, and 5 also. But 1 can't be here because we know one of these ones has to be a 1. This one can't be 1 either because one of these two have to be a 1. Hmm. This can't be 2. This can't be 1. Hmm. Okay, so the rest of this is what? 1, 2, 5, 6, and 7. Obviously, 2 can't be here. 1 can't be here. 7 can't be either of these two. One of these has to be 1 or 2, which means the other one has to be 1 or 2 here. Which means this can't be 1 or 2. This can't be 1 or 2. One of these is 5, 6, or 7. The other is not. If this is this can't be 3. This has to be 1 or 2. Which means this can't be the 2. You cannot have 1 or 2 in the rest of the column because we have a 1, 2, 1, 2 pair. Therefore, this can't be low that it goes to. It has to go here. So it has to go here, which means this is the low. It has to be 1 because it can't be 2. Therefore, this is 2. This is 1 then. The 7 is one of these two that goes to the 2. The 2 has to continue on here. This is 1, which means none of these can be 1. Which means this has to be 1 and this has to be 1. So it must connect this way. So these are both low and on the paths each. This can't be 1. I don't think it can ever go around here, right? If it tries to, it cuts off 6. So no, it can't. It has to connect somewhere here. So say it went 7, 8. This can't be, yeah, this would have to connect this way. So this has to be the 7 or 8. So this is 7 or 8. This can't be the 7 or 8. It must connect this way. So this is high. Oops. Which means one of these is low connecting to the 9. We're not sure which. It could be any of them. This can't be 1. This can't be 1. So it could connect with either of these to here. This one could go through here. This one connect this way. So this has to connect with a 9 here. This 9 connects somewhere here. This can't be 1 either. So 1 has to be one of these two. Hmm. 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 Where are the crab paths then? So this is connected to this. Okay, so say, okay, if this is connected to this, say this was the 8, this was a 7. This would have to connect somehow here, which means this would have to connect around this way, which is possible right now. Could go like this to, but then this would have to, I don't even know if that's possible actually. So say we did make this an 8. This was 8, this was 7. This 7 has to connect with the 6 somehow. Can it even go that way? This would have to be high, so it would have to be a 6, which would be next to 1 and 1, which is not possible. So this cannot be on the loop, if that's the case. Okay, so this can never be on the loop, right? It can't connect to any ones here, so this can never be on the loop. So this is not on the loop. This is not on the loop. Because it can't connect to any ones, right? This can't be on the loop because of the same reasoning, right? If this was 6... Oh, wait, no, this would be a low. So this could be on the loop. This can't be on the loop. This could be on the loop because it's low. This could be 6 and 1. That does actually work so far. So the 1's can one of these 3. This would have to be a high, though, that if it's on the loop, and therefore it would be 6, but it doesn't have a 1 next to it. Is this on the loop? It would have to be a high, so no, it cannot be on the loop. We don't know about this. So for this to go around, it would have to go all the way around here, all the way around here. It would have to cut back here because it cannot go to connect to here. But that's not possible. Yeah. So this can never be 7 then. Because if this is 7, this has to be 8. Connect somehow this way and then connect this way. Yeah, so this is 8. So this has to be 8, which makes this 7, which makes this 8. Which is fine, which makes this not 7, so this has to be the 7, which means this is the connection. So it has to connect this way. This can't be 7 anymore. So it's a 5, 6, 5, 6 pair. This is 8, so either one of those works. This is 7. Hmm. This has to be next to 1 and 2. So 1 and 2 have to be here, which means 1 and 2 cannot be any of these. So this could be 3, 4, 5, 6, 8, 9. 8 obviously can't be here. 9 can't be here. 1 and 2 have to be here. So this is connected this way. We're not sure where. This can't be 7 anymore, therefore this has to be the 7. So 7 has to be one of these 3. This is 2, 3, 4, 5, 6. This has to have an 8 and 9 and a 3 and 4. 7's one of these 3. 1 is one of these 3, and 2 is one of those 3 also. This can't be 9, this can't be 9. Okay. So say it tried to go around here. It's possible still, right? Yeah, because the 8 can connect with the 9. This is what? We have 3, 5, 6, and 8. And 1 could be here. This can't be 8, obviously. This is 3, 4, 5, 6, 7. So this can't be 7. What are the paths? This can't enter in and exit out anymore. So that doesn't work. So this one's not on the loop. It's not even a loop. It's I guess it's just one long line. It's not on the line. This would have to be a high next to it, so it cannot go this way. It still could go this way, though. That means it cannot be here because it would also have to be essentially connected. It could go here, in which case it would have to go here or here. Can it ever enter in this way? I don't think so, right? It would have to go here, then here, then here, which would be 7, 2, but then this would have to be low, and that would be 2, so that's not possible. So none of these can be on the line. If this was low, if this enters in this way, it has to be high. So this has to be 9, which would mean it's next to a low, which would be 3. So it cannot enter in this way specifically, right? Because if it tried, so this would be high, this would be high, this would be low, this would be high. The problem is this would have to be a 3 or 4. This would have to be the 7. So that's not possible. So it cannot enter in this way. So going specifically here is not allowed. I guess it could go that way. It seems a little weird. That would be 9, 1, and 2. 8, 3. It's possible. Okay, so this can't be 9 or 8. This is 1, 2, 3, 4, 5, 6, 7. This can't be 1 or 6, 2 or 7. Huh. This could be 9. This could be 9. So it could technically go something like that. It cannot go this way, though. So it must always enter this. So this must be a 1 or 2. So this has to be a low connected to here. It could technically go this way, then around back here. This is always a low, though, too. So this always has to be a low because it can't exit out this way. This has to be a high then. So this has to be, and it has to connect to here. So this can't be 6, this has to be 8. Which means this can't be 8, this can't be 8. These can't be 8. This would have to be 1, 2, or 3. So this could never be, I mean, it could be 3. I guess it could be 3, 8, and it could exit out this way. So this one actually does have to connect this way. Therefore, this one has to go this way. So this must be 6, 8, or 9. And it has to be high. It could go up. That would be a 3. But then it would have, well, This is not on the loop. Or whatever. Not on the line. We tried going this way. That would have to be high, this would have to be low, and this would have to be high. But I guess we never tried going this way, maybe. So this would be low, 3, 4. That would have to be 3, 9, 4, 9. So actually it could go this way. It just can't go through this way. So it could go around here. That's possible. Or it could just go here, then here, then here, then here, then that. That would be 3, 9, 4, then this would be 9, which actually does work. Ugh. It just can't go this way. It could go this way through there. It could go around here through here. It just has to go through here, essentially. Anyways, what else can it be? This can't be 3. This can't be 3. So we've got what? 4, 5, 6, 7, 8. Yeah, 4, 5, 6, 7, 8. This is 3 through 8. No 8. This could be 3, 4, 5, 6, 7, 8. This could be 3, 4, 5, 6, but no 7 or 8. This could be 3, 4, 5, 6, or 8. What do we have here then? This is 2 out of 1, 2, or 3. It could exit out here. Interesting. Where is the 6 crab walking to? So if this were 9, it went to 1, 2, 1, 2, 9. This would have to be 3, 8, 1 or 2. So 1, okay. Where is the 1 in column 6. It can't be any of these 6 because of these ones. It can't be this one because we know this one has to exit out this way. Can't be here because of this one, so this must be a 1. So this is a 1, which means this can't be 1. So it could exit out this way. That works actually fine. Could enter here, then exit here. That's fine too. There's a lot of possibilities still. 8 cannot be here anymore or here, so it has to be one of these two in box 5. That doesn't really tell us much. Okay, well, this can't be 8. Because this 8 cannot be 7 or 9. Can't be 6, obviously, because it's next to a 2 or 3. It still could be 1, 7, 2, 8, 3, 9, 4, which would make that 9. Which is fine going that way. Eight has to be one of these two. This is 2, 3, 4, 5, 6, and 9. That's pretty broad. These. If it ever goes here, it has to enter from here, which would mean this is 3 or 4. It has to exit this way. It can't go this way, so it would have to exit this way. So this can never be a low, because it would have to exit into a 7. This could be high, but it has to go specifically around that way. Interesting. And because it specifically it can't enter in this way, it can't enter it from here, because it would have to exit this way. So it cannot enter from here. Where can this enter from? It has to come from here, which means this can never just go straight through here. So this has to go down. So this has to go down. It could exit either of these two spots. That's fine. But it would be 2 and 8 if that's the case, which would make this 1. So this has to enter in here, which means this is a low. Because it's checkerboard pattern, it has to be high, then low. So this can never be 7. This has to be 2, 3, or 4, technically. 4 could work. So it has to enter in one of these two. We're not sure which. Therefore, okay, so it can't enter in either of these two. It has to go around here. So therefore, this is part of this path from the 4 to the 6. So therefore, this can never actually go back here. It does have to go this way. So I was right. It was going this way. And then it has to exit here. So it has to go here, and then it has to go here. These have to be low, so it's 3, 4, 3, 4. This has to be 9. This can only be 3 and 4. So therefore, this is 3, 4, 3, 4. It has to go this way. It has to enter here, which means it has to exit here. So this has to be, this can't be 3. This has to be 2, which makes this 1. This can't be part of the set, or the line. This can't be part of the line. This is 5 or 6. This is 5 or 6. So there's no 5 or 6 here. We have a 5, 6, 5, 6 pair in column 9. This can't be 5 or 6. This has to be 7 or 9, but it can't be 7 because it's next to a 3 or 4, so this is a 9. This has to be a high, so it has to be 7 to enter in. So therefore it has to connect this way because it can't enter that one. So this has to be a low. This has to be a high. This can't be 8 then. So this has to be 2, 3, or 4. It can't be 4, so this must be the 2. This can't be... This, well, we don't know. One of these has to connect, but this can't be 7. This can't be 1. So this can't be 1, this can't be 1. Therefore, this is the 1 in row 4. Because this is 1, this has to be 2. One of these has to be 2 to connect to the 7. This can't be 2, so this has to be the 2, and it has to connect. So this has to connect this way. So it has to connect here to here to here to here. Therefore, we know this is a 3. This can't be 2 or 3 anymore. This is 4, 5, or 6. None of them can go that way. Therefore, this path must go this way. This can't go this way anymore because this is blocked by this path. So therefore, it must go this way. This can't go this way anymore. This has to go here. So this has to be the path from 7, 6. This can't be... It can't go here because it can't exit out anywhere else. So it could technically go here. It still could go 6, 1. This one cannot go up there, though. So this has to go here. Which means it can't be 7. Can't be 8. This has to be 9. So this has to be a 9 here. This has to be an 8. This must connect this way because it's the only way. So therefore, this is 2, 3, 4. This can't go this way. Can't go this way because this is not 5 greater than this, so it has to go this way. So this is low and part of the loop. This is high and part of the loop. So this cannot be 3, 5, or 6 because that's not 5 away from any of those numbers, so this has to be the 8. This can't be 8 anymore. These can't be 8. These can't be 8. This can't be 8. Therefore, this is an 8. One of these is high. And it has to be next, if this was high and next to 6, it would have to be next to a 1. So that's not possible. So this has to be the 6 and high. So it's next to a 1. So therefore the path goes that way. So this is the high. This is the low. This can't be 6 anymore. This can't be 6 anymore. This can't be 6. There's no 6 here. This is a 4, 5 pair. Therefore this cannot be 4, 5. Therefore this must be a 3. This must be 5 then. This can't be 3. This has to exit to a high. So this has to be 7 and a high. But they cannot go to a 3, so it must continue on and go next to a 2. So this is 2. So it must continue here to here to here. This would have to be a 4, but 8 can't be next to a 4. So 8 has to be next to 3 and then 9. So that's that path. So this is low, this is high, this has to be a, not green, it's a 4. So this can't be 4, this can't be 5, this is a 3, this can't be 4, 5, so this is 6. This can't be 2, cannot be 2, so this can't be 2. This can't be 2, so this must be a 5, which makes that a 4, which makes that a 5, which makes this a 3, 4 pair. This can't be 3, 4, or 5, so this is the 2. And therefore, it has to go this way. Because it can't go next to the 5. So this is the low and on the path. There it goes here. It must continue from here to here to here. This has to be a 7. Because it has to be next to a 2, which makes this a 2. This can't be 3 or 4, 3, 4. So this can't be 7. This can't be 7. Either one of these works right now. This can't be 5, so it can't... This is a 5, so it can't be on the line. There is no 3 here. There's no 3 or 7 here. This is 4 with 5 or 6. So it cannot go up. This one has to go sideways. So it has to go here. This one cannot work because it must be be next to 1 and 2. So this has to be the 7 and it has to be the high. So this is the path there. So the 1 goes to here, 2 here. This has to be 9, 3, 8. This can't be 2. This can't be 2. This is 3 or 4. It can't be 4, so there must be 3. Which means there's no 3 here, no 3 here. This can't be 8 or 9. This has to be a 6, which means this must connect with a 1. So it has to connect this way, which means this is low. This has to be high. So it has to be 9. Cannot be 7, 8, or 6, so this is 9. Neither of these can be 9, therefore this must be a 9. We have a 3, 4, 3, 4 pair, so this can't be 3 or 4, so this must be 8. Which means this can't be 8, so this cannot connect this way, so this must connect this way. So it has to connect here, then... this would have to be 6 or 7, so it can't go up that way, so it has to go there. This can't be 4 or 5. This can't be, this is 6 or 7. This is 6 or 7. This is 4 or 5. So this is the high. This can't be 7, so this is 6, which makes that a 7. This can't be 6 anymore. You also have no 8s in the rest of the column, so 8 has to be here. This can no longer go this way because it doesn't have a 2 or a 1 available, so it has to go down, which means this is a 2, and it has to go this way, so this is high part of the path. This is 8. So it could go here. It cannot go here because this is only 4 or 5. This can't be 6. This can't be 6. This can't be 7. So this is a 5, which makes this a 6, which makes that a 5. This is 4. This is 6. It cannot go this way because 4 and 5 are not 5 away from both 8 and 9. So this has to go this way. It's a 3. So this is low. And we have the path now. So this is the path. We can gray out everything else. Gray out everything else, which is not part of the path. This can't be 6. This can't be 2. This can't be 6 because this is a 6. So this is 5, which makes that 6. This can't be 4 because it's next to an 8. So this is 3. This is 4. This can't be 3 or 4. So this is 5. This can't be 3, 4, or 5. So this is 6. This can't be 3 or 6. This can't be 3. So this is 4, which makes this 3, which makes that 4. This can't be 5. So this now must be a 4. This has to be 5. This is a 4. This can't be 4, 5, or 6. So this is a 3. And therefore, this is a 5. And that's a solution. Yeah, took a little while to get through to understand sort of the restrictions that we had. Makes a lot of sense. Yeah, it was kind of fun. Though it was a little harrowing at the beginning to not know whether you could have multiple crab paths enter in the same cell. It was pretty clear, I guess, but it was hard to distinguish specifically. Because the multiple crab paths was removed from the can't enter the same cell. So, yeah. Anyways, that's the solution. I hope you enjoyed the solve, and I'll see you next time on Frank Puzzles. Take care.